Hey guys, Mrs. Trivia here. Today we're going to talk about factoring special cases. Our learning target for today is that you can factor quadratic expressions with special cases and recognize those as we go. Let's jump in and first do a little bit of review of what we've done so far. Here are two examples for us that I want to do together. The first one I notice has a 1 in front of the x squared term. That means its coefficient is 1, and I can jump right to unfoiling it with two parentheses. I know the first term is made by x times x, so these must each be x's. And then the last ones had to multiply to become 9 and add to become 6. The only ways to make a 9 are with 9 and 1 and 3 and 3. 3 and 3 also add to 6, so I'll use plus 3 and plus 3. When a thing is written like this, where it's x plus 3 and x plus 3, I can rewrite it to just say x plus 3 squared, since it was written twice. Let's try the next one. I notice there's a 2 out front, but I also notice there's no GCF. Nothing goes into all three terms. So at this point, I'm going to use the box method. Let's draw a box. In the first box, I'll put 2x squared. In the last box, I'll put a 3. I'm looking for factors of a times c, which is 6, that add to 5. The only ways to make a 6 are 1 times 6 and 2 times 3. 2 and 3 would make a 5 if we added them. So I'm going to use 2x and 5x. Now, if we go through and find our factors for each row and column, let's look at the first row. They each have 2's, so I can pull that out, and they each have x's. The next column, there's 5 and a 3, and there's no GCF there, so I can only plot a 1. The first column, they each have x's, so I can pull that out. And in the next column, there's nothing in common, so I can pull out a 1. I now have my two factors on the column and row, 2x plus 1 and x plus 1. Let's move forward and look at something new today. Here's a new one, and what looks different about it is the fact that there's no term in the middle here that we normally see with an x. It's like there's 0 there. Matter of fact, let's write it that way and work it out the same way as we normally would. So in this case, there's no GCF, and I'm looking for factors of 9 times negative 4. Let me set up my box, I forgot about first. 9x squared, 4. I'm looking for factors of 9 times negative 4, which is negative 36, and I want them to add to be 0. The way to make a 36 is 1 and 36. 2 goes into it, 2 and 18. 3 goes into it, 3 and 12, sorry. 4 goes into it, 4 and 9. And 6 times 6. With this list, one of the two numbers is negative. The only way to make a 0 is if I use negative 6 and positive 6. So I've got negative 6x and positive 6x. Now let's look for our factors. Between 9 and 6, you can factor a 3 out. And between x squared and x, you can factor out an x. Between 6x and 4, you can factor out a 2. First column, between 9 and 6, again, you can factor out a 3, and they each have x's. And then between 6 and 4, you can factor out a 2, and I'm going to pull the negative since it's closest to it. I notice I have 3x plus 2 and 3x minus 2. That is my final answer, and I want to show us at this point why this is a special case. But essentially, since there's a 0 in between, it always works out to be the square root of that number. So how we can play this out and make it a bit faster for us is notice the relationship between the number in front of x squared, 9, and the first number, 3. The square root of 9 is 3. Our second number is 4, and the square root of 4 is 2. That means the second number is 2. Let me show you that trend in another one where we can see the pattern a little bit better. This one is in the same setup. There's no v term, and both 16 and 25 are perfect squares. So I can set myself up with two parentheses and essentially take the square root of each of these numbers. So let's do the first one, the square root of 16v squared. 16 is perfect, so it comes out of 4. And v squared is perfect, so it comes out of v. So the square root of 16v squared is 4v. That goes in my first spots. The square root of 25 is 5. Those go in my second spots. Since I'm trying to add to get 0, it means one's positive and one's negative. So the trick here is if you have two things that are perfect and no v term, you can take the square root of each of them to set up your parentheses. Let's try another. Number 3, 25 is perfect, 9 is perfect, there's a negative in between. So let's set up our parentheses. The square root of 25 is 5, and the square root of x squared is x. So 5x goes in each of the first spots. The square root of 9 is 3, so those will go in the second spots. I need one positive and one negative, and that's it. A lot quicker for this special case. I think I'd like you to try this one on your own. Please take a moment, pause your screen, and see if you can get this one. All right, let's see how you did. Did you get p plus 4, p minus 4? I hope you did. That's what this one should work out to be. The next couple examples I have are kind of reviewing what we've done so far in other lessons as well. So here's a new one. It looks a little bit different. What looks different to you? If you thought to yourself that it's in the wrong order, man, you're right, because usually the k squared term comes first, and then the k term, and then the constant. So if I rework this, now it looks pretty normal. I can look for a GCF between 8, 10, and 3, but there isn't one. So I'm going to jump right to box method. In my box, the top left corner will be from the first term, 8k squared, and the bottom will be 3. I'm looking for terms that multiply to become 8 times 3, or 24, and are negative 10 apart. Since it's negative, I know each of these will be negative. Let's look at the ways to make 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's the end of our list. The only one of these on the list that could make a 10 when they're both negative would be 4 and 6. Be careful, you might have thought it was 2 and 12, but if those are both negative, it'd be too much. So negative 4x and negative 6x are the ones we need. From our first row, we can pull out from the 8 and the 4 a 4, and from the k's, a k. Whoops, I switched variables at some point. This should be a k, and so should this one. All right, on my next column, or I'm sorry, row, I've got negative 6 and 3, means I can pull out a 3, and since the negative's on the closest ones, I'll use a negative. From the first column, between 8 and 6, I can pull out a 2, and they each have k's. And then between the 4 and the 3, I can't pull anything out, so I'll use a 1. My final answer here is 4k minus 3 and 2k plus 1. Let's try one last one to make sure we've got it all together. Number 6 is already in the right order for me with the squareds, then the x's, and the constants. I do see a GCF that I can pull out. Between 4, 10, and 6, 2 is a common factor. If I pull out a 2, I'm essentially going to divide each term in here by it. 4 divided by 2 is 2. 10 divided by 2 is 5. And 6 divided by 2 is 3. At this point, I'll set up my box. At one point here, I would always see students make mistakes where later when they get to their final answer, they forget about this 2 we factored out. So my advice is at this point, set up your 2 parentheses for your answer and set the 2 in front of it. That way you don't forget about it. All right, let's finish this problem. Our A and our C are 2 and negative 3, so that's negative 6. Ways to make negative 6 are with 1 and 6, or 2 times 3. I need these to both be adding to negative 5, and I need one of them to be negative. That means I'd need negative 6 and positive 1. Negative 6x plus 1x. From the first row, I have 2 and 6, so that means I can pull out a 2, and they each have x's. From the next row, there's nothing in common, so I can only pull out a 1. From the first column, they both have x's. And the second column, they both have 6 and 3, so I can pull out a 3, and I'll make it negative. I have 2x plus 1, and x minus 3. That's the last one for today, guys. I will see you next time, and we'll continue looking at factoring. See you then.